Hello students, once again welcome to the LJ Institute of Engineering and Technology. Let's start with the course Mathematics 1. Myself Krunal Patel, Assistant Professor. In last lecture we have seen the chapter Taylor and Maclaurin series. In last lecture we have seen the formation of Taylor series, different forms of Taylor series and example based on form 1. Today we will see the Taylor series again but with different topic. Like first we will see the review of different forms which already learned in previous lecture. And second and third topic is example based on form 2, 3 and 4. One by one we will see. So let's take a review, or we can say that a recall of different forms. Form 1, Taylor series in powers of x minus a. Whenever function f of x is given and asked to expand the function f of x in powers of x minus a, then we will use this form. F of x is equal to f of a plus f dash of a by 1 factorial into x minus a plus f double dash of a by 2 factorial into x minus a whole square plus f triple dash of a by 3 factorial into x minus a whole cube plus and so on. By using this form 1, we can obtain form 2, which we have already seen in previous lecture. The Taylor series in power of h. By putting x minus a is equal to h, x becomes a plus h and x minus a becomes h. So we have the Taylor series f of a plus h. So whenever in example asked that expand f of a plus h in powers of h, then we will use form 2. So we have f of a plus h is equal to f of a plus f dash of a by 1 factorial into h plus f double dash of a by 2 factorial into h square plus f triple dash of a by 3 factorial into h cube plus and so on. Now from 2 we can obtain form 3, which also we learned in previous lecture, which was Taylor series in power of h. How we find form 3? Just by replacing a by x. We will get f of x plus h is equal to f of x plus f dash of x by 1 factorial into h plus f double dash of x by 2 factorial into h square plus f triple dash of x by 3 factorial into h cube plus and so on. So if function is in the form x plus h and we want to expand that function in power of h, then we will use form 3. Now form 4, Taylor series in powers of x. This form is reduced form from form 3 by just interchanging x and h. So we have function of h plus x and in power of x. So form 3 and form 4, in these two form only difference is in form 3 function was f of x plus h and in power of h, and in form 4 we have function of h plus x and power in power of x. So we have f of h plus x is equal to f of h plus f dash of h by 1 factorial into x plus f double dash of h by 2 factorial x square plus f triple dash of h by 3 factorial x cube plus and so on. So we have these 4 forms, but example based on form 1 we have already seen in previous lecture. So in this lecture we will see the mixed examples of form 2, 3 and 4. So let's start with the examples. First example, show that log x plus h is equal to log h plus x by h minus x square by 2h square plus x cube by 3h cube plus so on. So here we can see that power of x is given. So we have to expand this function in power of x, and function is of x plus h. So we need which form that we have to think. So let's start, then we will see which form will be used in this example. So solution, let f of x plus h is equal to log of x plus h. So function is x plus h and we want to expand this function in power of x. So we will take function f of h. F of h is equal to log h by dropping x. So now by Taylor series we will use this form f of x plus h in power of x. If function f of h and in power of x, then this function become f of h, f dash of h, f double dash of h and so on. So we differentiate f of h successively. So let start with first derivative of f of h is equal to log h. We have f dash of h is equal to 1 by h. We know the differentiation of log. Now second derivative, f double dash of h is equal to minus 1 by h square. Third derivative, f triple dash of h is equal to 2 by h cube and so on. By putting all this f of h, f dash of h, f double dash of h, f triple dash of h in equation 1, we have f of x plus h is equal to f of h is log h plus x by 1 factorial as it is, f dash of h is 1 by h plus x square by 2 factorial as it is, f double dash of h is minus 1 by h square plus x cube by 3 factorial as it is into f triple dash of h which is 2 by h cube and so on. Just by simplifying this form we have our final answer, log of x plus h is equal to log of h as it is plus x by h minus plus minus minus x square by 2 into h square plus x cube by 3 factorial means 6 into 2 by h cube. By cancelling 2 with 6 we have 3. So x cube by 3 into h cube plus so on. This is our final answer. So in this example we have seen that function was log of x plus h. That means function is the form of x plus h and we need to expand this function in power of x. So we used this form, function f of x plus h in power of x, the form 4. Now one more example. So we have example, expand sine pi by 4 plus x in powers of x. Here we need to expand this sine pi by 4 plus x in power of x. So in power of x, that means function of h. So we will use form 4 again. After expanding this, Also we want to find the value of sine 44 degree and sine 46 degree by using the expansion of sine pi by 4 plus x. So let's start with the solution. Here f of x plus pi by 4, that means f of pi by 4 plus x, we can say either of this. So here f of pi by 4 plus x is equal to sine pi by 4 plus x. So therefore f of h plus x is equal to sine h plus x. So h becomes pi by 4. So we have f of h is equal to sine h, because we want to expand in power of x, so we will take function f of h. Now by Taylor series we have the formula, okay, form 4. Now by differentiating f of h successively and by putting the value of h is equal to pi by 4, we have first f of pi by 4 plus x is equal to this f of h become f of pi by 4 plus x by 1 factorial, f dash of h become f dash of pi by 4. Wherever h appears we will put pi by 4. Now by differentiating f of h is equal to sine h, we have f dash of h is equal to cos h. Again differentiate with respect to h, minus sine h. Again with respect to h we have minus cos h. And in this all derivative we will put the value of h is equal to pi by 4. So we have sine pi by 4 is 1 by root 2, cos pi by 4 is 1 by root 2, minus sine pi by 4, that means minus 1 by root 2, minus cos pi by 4, that means minus 1 by root 2, and so on. Now put all these value in equation 1. So we have this form, f of pi by 4 plus x is equal to 1 by root 2 plus x by 1 factorial 1 by root 2 plus x square by 2 factorial minus 1 by root 2 plus x cube by 3 factorial minus 1 by root 2 plus and so on. By taking root 1 by root 2 common, we have 1 plus x minus x square by 2 minus x cube by 6 plus dash 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 and so on. Say this equation number 2. So this is the expansion of sine pi by 4 plus x in power of x. Now we have the example in which we want to find the value of sine 44 degree and sine 46 degree. So how we can find the sine 44 degree and sine 46 degree by using this expansion? Let's have a look on this. So first we want to find the value sine 44 degree. We know that sine 44 degree, that means sine 45 degree minus 1. Why we take this 45 degree? Because we have the expansion of sine 45 plus x, that means pi by 4 plus x. So we just write down 44 degree by 45 degree minus 1 degree. So by comparing this sine 45 degree minus 1 degree with sine pi by 4 plus x, we have x is equal to minus 1 degree. Now we have to convert this degree form into radian form. We know that we have to multiply this minus 1 by pi by 180. So we have minus 0.0174533, which we have by using calculator. Okay. Now put the value of x in equation 2. So we have sine 44 degree is equal to 1 by root 2 as it is, and we know the equation number 2. Wherever x appear, we just put the value of x, x and x. So x, x square and x cube and so on. And by using calculator, we have the approximate value of sine 44 degree which is 0.6947. You can also verify by scientific calculator directly sine 44 degree, which is also nearby this. Now we will find the value of sine 46 degree. Same process, that means sine 46 degree is equal to sine 45 degree plus 1 degree, and by comparing this with sine pi by 4 plus x, this time we have x is equal to 1 degree. Again convert this degree into radian, we have same value but not minus sign. Now put this value x in equation 2, so we have this 1 by root 2 and similar way, and by calculating this we have the value of sine 46 degree is equal to 0.7193 approximate. So in this example you have seen how we can find the value of a known angle by using Taylor series. Nowadays we have calculator, but before we don't have the scientific LC, so Taylor's define the series to calculate some kind of unknown value of trigonometry and as well as other function. Now let's have a look on another examples. One more example, we have this. Using Taylor's theorem, evaluate under root 36.12 up to 4 decimal places. Now we know the value of under root 36, that means square root of whole number we can calculate, which is already perfect square, but 36.12 which is unknown. So by using Taylor series, how we can find the value of under root 36.12? Let's have a look. So here under root 36.12 is equal to under root 36 plus 0.12. 36 known value and 0.12 is unknown value. So just remember this. Now take x is equal to 36 and x is equal to 0.12. So take known value as x and unknown value, root of 0.12 is unknown, that's why I am saying that unknown value, and unknown value as h. So we have function f of x plus h is equal to under root x plus h. So this is our function. Now we have to expand this under root x plus h in power of h, unknown value. We will expand this in power of h, that means the unknown value whose square root we don't know. So take f of x is equal to root x by Taylor series in power of h. Now we will use the power of h, that means form 3. So just by putting the value of x and h, we have this series. So we will find f of 36, f dash of 36, f double dash of 36, and to find all this value we have to differentiate f of x is equal to root x. So first let's start f of x is equal to root x. So f of 36 is equal to under root 36, and which is 6. Again differentiate with respect to x, 1 by 2 under root x, and by putting the value of x 36 we have 1 by 2 under root 36, that means 1 by 2 into 6, that means 12. Again differentiate with respect to x, again put the value of x which is 36, we have the value, and so on. By putting all this value in equation 1, we have this series, and by using calculator, by multiplying and adding this term, we have approximate value of under root 36.12, which is 6.0099. Okay, so this is the process how you can find the square root of unknown numbers. Same way, we have one more example which you can also calculate by same way. Have a look on this example. We'll see by quickly. Sine 30 degree plus 30 minute. So x is equal to 30 degree, that means pi by 6. 30 minute, this means 30 by 60 into pi by 180. So we have pi by 6 plus 0.0087. So take x is equal to known value, x is equal to unknown value. So we have function f of x plus h is equal to sine x plus h. So we'll take f of x is equal to sin x by Taylor series. We have the series in power of h by putting the value of x and h. This series is formed, say equation number 1. Now differentiate the function f of x is equal to sin x and put the value of x is equal to pi by 6. We have these derivatives and substitute all these derivatives in equation 1. We have this series, and by simplifying, by using calculator, by adding this term, we have the approximate value of sine 30 degree 30 minute is equal to 0.50752 approximate. So now same way you can calculate these examples by using form 2, 3 and form 4. Which form is used for the example that you have to identify, and then by using that form you can expand and find the approximate values. Okay, you can use any form and you can find the approximate value of sine 43 degree, under root 25.15 and cos 64 degree and so on. Okay, so these are the second topic of Taylor series. Here we are finished with the Taylor series. In next lecture we will see the Maclaurin series, and in that series we will see the standard expansion or standard special Maclaurin series and some example based on that Maclaurin series. Thank you for watching. Keep watching and always try this DIYs. Thank you.